We will finish section 1.4 in this video. Let f of x equals 2x squared minus 5x minus 9, and we want to find the slope of the tangent line to the graph of f of x at the point 4, 3. Let's find the point 1, 2, 3, 4, 1, 2, 3. So this is the point 4, 3. And we want to find the slope of the tangent line at that point. So let's first look at what the tangent line might look like. This will be hard to draw because this graph is almost vertical at the point 4, 3, but the tangent line will look something kind of like this, where it's going to barely touch the graph, and I'm sorry I'm not drawing it straight, but hopefully you get the idea. Where it's going to barely touch the graph without actually going through it. That'll be our tangent line, and we want to find its slope. So remember, the slope of the tangent line is equal to f prime of x, which is also called the derivative, which is also the instantaneous rate of change. They're all the same thing. Slope of the tangent line equals to the derivative, which is f prime of x. That's equal to the instantaneous rate of change. And all of that is given by this formula. Limit as h approaches 0 of the difference quotient, which is f of x plus h minus f of x all over h. All right, so let's first figure out what f of x plus h is. And again, I will go through this quickly since we've done so many of these examples, but if something doesn't make sense, please do ask it in class. Our input is x plus h, so we have f of x plus h 2 times. Instead of x squared, we have our input, which is x plus h to the second power, minus 5 times x plus h minus 9. So f of x plus h equals to 2 times, if I FOIL this, I got x squared plus 2xh plus h squared minus 5 times x plus h minus 9. So f of x plus h is equal to 2x to the second power plus 4xh plus 2h squared minus 5x minus 5h minus 9. That's just f of x. Now let's put it all together into this formula. So we want the limit as h approaches 0, and I'm going to have to write pretty small, I think. So we got f of x plus h, which is 2x squared plus 4xh plus 2h squared minus 5x minus 5h minus 9. That's f of x plus h minus f of x, which is 2x squared minus 5x minus 9. And all of that is divided by h. Now, as we know, anything that doesn't have an h term in it is going to cancel. So for example, this 2x squared and this negative 2x squared, that's going to be 0. We have a negative 5x minus negative 5x. That becomes a positive 5x, so the negative 5x and positive 5x cancel. We have a negative 9 minus negative 9, so those also cancel. And all we're left with is this. We have limit as h approaches 0 of 4xh plus 2h squared minus 5h. So basically all the terms within h, and then all of them are divided by h. So if we simplify this, we have limit as h approaches 0 of 4x, h squared over h is 2h, and then minus 5. So what's our point? The value of x is equal to 4. H is approaching 0. So if I plug this in, I'm going to get 4 times x, which is 4. X is 4. Plus 2 times h, which is 0, minus 5. So my slope m is going to be 4 times 4, which is 16, minus 5, which is 11. Okay, so the slope of this line, the tangent line at the point 4, 3, it's equal to 11. So we're going to go up 11 over 1. Now we want to find the equation of this tangent line of f of x at the point 4, 3. So the equation of any line is in this form, y equals to mx plus b. We know what the slope is. The slope is 11. We need to find out the y-intercept. So for that, we take the point 4, 3, and we plug it in. So we replace the y value with 3. We replace the m, or the slope value, with 11 from here. We replace the x value with 4, and we got plus b. So at this point, we got 4, 3. We got the slope, which is 11, and so we plug all this in to the y equals mx plus b equation. So we have 3 is equal to 44 plus b. We subtract 44 from each side, and we end up with negative 41 is equal to b. So our equation of this tangent line is y equals to 11x, slope is 11 from this formula, minus 41. Okay, let's do one last example. Find the instantaneous rate of change of f of x equals 2x squared plus 4x plus 3 at x equals 3, and then find the equation of the tangent line at the point 3, 33. So to find the instantaneous rate of change, remember, it's always using this. We have limit as h approaches 0 of f of x plus h minus f of x, all of that divided by h. So first, let's find f of x plus h. So if our input is x plus h, that means we're going to have 2 times x plus h to the second power plus 4 times x plus h plus 3. So this is 2 times x squared plus 2xh plus h squared plus 4 times x plus h plus 3. Distribute, we got 2x squared plus 4xh plus 2h squared plus 4x plus 4h plus 3. Okay, so we distribute all of this, distribute the 4, and that's going to be f of x plus h. Now let's take this and plug it into our formula. So we have the limit as h approaches 0 of parentheses f of x, that's that big old thing. And I mean, really, at this point, if you want, you can just cross out the 2x squared and the 4x and the 3, because we know that only the terms with the h's are going to be left over. But that's only if you want to use a shortcut. If not, let's write this all down. We got 2x squared plus 4xh plus 2h squared plus 4x plus 4h plus 3. That's f of x plus h. Then you got minus f of x. So what's f of x? It's this thing right here, which is 2x squared plus 4x plus 3. And all of that is divided by h. So 2x squared minus 2x squared is 0. We have 4x minus 4x is 0. We have 3 minus 3, that's 0. So what do we have left? We have limit as h approaches 0 of 4xh on the numerator plus 2h squared plus 4h, and all of that is over h. So we have limit as h approaches 0 of 4x, that's gone. H squared over h is 2h, and then h over h is 4. So h is approaching 0. The value of x is equal to 3. So this is going to be 4 times 3 plus 2 times 0 plus 4, which is 12 plus 4, or 16. So the slope of the tangent line at the point x equals 3 to this curve, to this parabola, is 16. Okay, that's the slope of our tangent line. But now we want to find the equation of the tangent line, which is going to be in the form of y equals to mx plus b. We know what the x is, we know what the y is, and we know what the slope is. The slope m is equal to 16. So let's plug this all in. The value of y is 33. The value of m is 16. The value of x is 3. And you got plus b. So this is 33 equals to 48 plus b. We subtract 48 from both sides, and this gives us b is equal to negative 15. So our equation of the tangent line at the point x equals 3 is y equals to our slope, which is 16x, plus our y-intercept, which is negative 15. Here's a summary of this lesson. The instantaneous rate of change, which is same thing as the slope of the tangent line, which is same thing as the derivative, is this limit as h approaches 0 of f of x plus h minus f of x all over h. In order to find the derivative, which is same thing as the slope of the tangent line, we apply that formula.